Now, here are the solutions for the multiple choice questions on the review that didn't already have a video solution. Many professional schools require applicants to take a standardized test. Suppose that 1,000 students take such a test. Several weeks after the test, Pete receives his score report. He got a 63, which placed him in the 73rd percentile. This means that, and so percentile is the number at or below the same score divided by the total, and it's changed to a percent. So since he's in the 73rd percentile, that means 73% scored at or below what Pete scored. For the normal distribution shown, the standard deviation is closest to what? So we're going to compare to the standardized distribution. So I went ahead and got on Stapplet and created a little one with -3 to +3. And I went ahead and lined it up roughly, and I can see that -3 looks like it's at -7, and +3 looks like it's 11, so that's 6 standard deviations apart. The width is 11 minus -7, which is 18, so that's that top width right there, right? Let me do my laser pointer so you can see what I'm saying. So this top width right here, right, from here to here is about 18, which is 6 standard deviations apart. So we divide by 3, and we get, oh, each one of these standard deviations must be close to 3. Number 9, the figure shows a cumulative relative frequency graph of the number of ounces of alcohol consumed per week in a sample of 150 adults who report drinking alcohol occasionally. About what percent of these adults consume between 4 and 8 ounces per week? So I know the ounces, and I'm going to figure out the percents. So starting at 4, I find out that's at the 20th percentile. Starting at 8, I find out that's about the 60th percentile. And I just take the difference, and I get 40%. Number 10, the average yearly snowfall in Chillyville is approximately normally distributed with a mean of 55 inches. If the snowfall in Chillyville exceeds 60 inches in 15% of years, what is the standard deviation? So we know 15% of years are above 60 inches. That tells me that 85%, 100% minus 15%, are below 60 inches. It's at the 85th percentile. So I'm going to go ahead and use Stapplet to go from here. So I'm going to go ahead and go to the normal distribution Stapplet. Now this is a multiple choice question, so I would be tempted to just put in the actual mean of 55. But the problem is it's asking me for the standard deviation, and I can't do that. So that means I have to use a standardized curve where I have 0 and 1, the z-score curve. So if I plot my distribution, it will be like that. So I know I want left, right, to the left. And if I put my 0.85 here and I hit calculate area, always show your labels on your plot here so you can make sure. So let's use this support, this scaffolding, so you can immediately see that Mrs. Overman made a mistake. Might have been on purpose. Actually, when I was starting to play with it, I started to do that. So I did actually make this mistake. I was like, oh, look at that. Isn't this awesome? It showed me my mistake because I forgot to do something. This is value, not area. And I'm putting in a value to calculate an area, but I don't want to calculate an area. I want to calculate a value. So let me switch to that. And we said it was in the 85th percentile, and we can calculate our z-score there. Now, and go ahead and show your labels, make sure we have the areas correct. And everything is looking good. So I have a z of 1.04. Now, did I have to do the percentile? Could I have just used a 15%? Absolutely. Just remember that you're on right tail, 0.15, calculate value, and you'll see that your z-score is unchanged. So either method is fine. You can actually say, oh, I like percentiles. Percentiles are nice. But you can just calculate the value for the area that's specified. In this case, we said 60 inches was the mark for the upper 15%, and there you go. So now we have our value, we have our z-score, we have our mean, and we're trying to find out our standard deviation. And we bring up this formula that you should be very familiar with, and we substitute in what we know. We get 1.04 equals 60 over minus 55 over the standard deviation, or 5 over the standard deviation. Then I multiply both sides by standard deviation, divide both sides by 1.04, and I get 4.83. Number 11. The figure shown in the density curve is the density curve of the distribution. 7 values are marked on the density curve. Which of the following statements is true? Well, the area under density curves is always 1. That's the whole idea. So that should be true. A should be our answer. But let's check the rest. The area between, let me get my laser again. So the area between B and F, so there's B and F, that looks like it's more than half. So I'm going to say that is not true, all right? The median says the median of the distribution is C. Well, it should cut the area in half, not the width in half, but the area. And you can see if I cut this in 2 parts here, I've got all this over here. So that's definitely not it. For D, I think I have, for D to be Q1, Q3, it should say Q3, I got a little typo here. That means I need to have only 75% of the data to the left, and that is not true. And it's very difficult to determine a mean from either a cumulative distribution function, actually this is just a density curve, it's not a CDF, sorry, and a histogram. So try not to find means too much. Technically, they're the center of gravity, so they're kind of cool. But it's very difficult to find on here. So typically, if they're asking you for the mean from something like this or a histogram, or they say the answer is the mean, it probably isn't because you don't know how to calculate it. Okay, so the correct answer is, as we suspected, the area under the curve between A and G is 1. If the heights of a population of men are approximately normally distributed, and the middle 99.7% have heights between 5 feet and 7 feet, what is the standard deviation of heights in this population? So I went ahead and used Staplett to draw my empirical rule, which is basically 99.7% of the data is within 3 standard deviations of the mean. So this width from -3 to 3, from -3 to 3, right? -3 to 3 is, it is 6 standard deviations, right? Now, what's the width here between 5 foot and 7 foot? Well, 7 foot minus 5 foot is 2 foot. But notice these are in inches, so I got to change it to inches. And I know this is 6 standard deviations wide, so I divide by 6, and I get a standard deviation of 4. Number 13, the distribution of time it takes for different people to solve a certain crossword puzzle is strongly skewed to the right, with a mean of 30 minutes and a standard deviation of 15 minutes. The distribution of z-scores for those times is what? Well, first of all, if we're talking about z-scores, because let's say I put there we go. Let's say I put in the mean for the mean. The z-score for the mean is always 0, right? So z-score distributions always have a mean of 0, and they also always have a standard deviation of 1. Now, so that means it's either D or E. Is it normally distributed? Or is it skewed to the right? Well, let's think about it. If I have an outlier, right, that's skewing the original to the right, they're also going to have very high z-scores. So the z-scores, you'll have some really high z-scores, you'll have some outliers on the z-score distribution. So the correct answer is skewed to the right because of those outliers. Their z-scores will not suddenly go down, they'll still be high. Number 14, the Environmental Protection Agency requires that the exhaust of each model of motor vehicle be tested for the level of several pollutants. The level of oxides of nitrogen, NOx, in the exhaust of one light truck model is found to vary among individual trucks according to an approximately normal distribution, with a mean of 1.45 grams per mile driven and a standard deviation of 0.40 gram per mile. All right. which of the following best estimates the proportion of light trucks of this model with NOx levels greater than 2 grams per mile? So I'm going to go ahead and write down the values I know. And I was being good. I said, hey, let me write down what it's asking for too. Good habit. So I have the mean, I have the standard deviation, and I want to know the probability that it's greater than this. So I'm going to do this using z-scores. So z equals value minus mean. And I can get 2 minus 1.45 is all over 0.4, and I get a z-score of 1.375. And if I put that in and say to the right, because we're trying to go to the right, it gives me an area of 0.0846, which is our answer there. And I'm also going to show you how to do a shortcut, since we actually do know the mean and the standard deviation. So this is how I had Staplets set up to calculate the area right there using z-scores. But I could jump straight to the mean and standard deviation if I know them. So it's 1.45 is the mean. The standard deviation is 0.4. And instead of putting in the z-score, I will put in the actual value, which is 2. We wanted 2 to the right. And you can see it actually calculates my z-score for me there. And it shows the area. So you can jump to putting in the mean and standard deviation directly into the Staplet, whether you're going forwards or backwards. It doesn't matter. But the key is you have to have the mean and the standard deviation in the original units for this to work. If you're missing either one, you really need to use the standardized z-score distribution. Number 15, until the scale was changed in 1995, SAT scores were based on a scale set many years ago. For math scores, the mean under the old scale in the early 1990s was 470, and the standard deviation was 110. In 2016, the mean was 510, and the standard deviation was 103. Gina took the SAT in 1994 and scored 500. Her cousin Colleen took the SAT in 2016 and scored 530. Who did better on the exam, and how can you tell? So remember, we can compare apples and oranges by using z-scores. So let's first start with Gina. Her SAT was 500, the mean for that time frame was 470, and the SD was 110. So we'll calculate her z-score, 500 minus 470 divided by 110. So we get 0.273. Then we'll take Colleen's data, 530, mean of 510, and an SD of 103. So substituting in 530 minus 510 divided by 103 is 0.194. So we can say who has the higher z-score? Gina does. So since this is a standardized score, we know that she did better. Number 16. The professor's DeLorean has a wide range of speeds that it can achieve depending on traction. The distribution of speeds follows an approximately normal distribution with a mean of 80 and a standard deviation of 7.7 miles per hour. Which of the following is the best description of the standard deviation? So actually, I don't need to know that it's normal. The answer is the same, regardless if I said this was a skewed right distribution or a uniform distribution or even a bimodal distribution. There is a definition for standard deviation that does not depend on the type of distribution. It is the typical distance between the data points and the mean. So it's not the distance between the highest and the mean. It's not the distance between the slowest and the highest, so B and C are out. Here it says approximately the mean difference, which would be like the typical distance. But it says median here. We need it to be the mean difference between the individual data points and the mean. So the correct answer is E. Good luck on your test.